Good afternoon, everybody. Welcome to the beginning of Chem 170 with your host, me, Dr. White. Hi, everybody. Welcome to the beginning of the semester of organic chemistry. Now, during the semester, you'll learn a lot about me. And the first thing I'm going to teach you is if we were face-to-face, I'd have my hearing aids in. Obviously, I don't because up here above my monitor on the shelf, I have these huge amplified speakers, so I can crank up the volume. However, that still means once in a while, I have trouble hearing what you say. And if I ask you to repeat it once or twice, that's my problem, not yours, but please bear with me. And it would happen face to face too if we were in a classroom, but I'd have my hearing aids in. I'm not as bad as my older sister or my mother was. I have about a 60% hearing loss. They have about, or my sister has about 80%. All right, let's get going. All right, the first thing I want to talk about is probably the most important thing I will teach you today. And that is, in my class, in my world, there's no such thing as a dumb question. I'll say that again. In my class, in my world, there's no such thing as a dumb question. It took me until my third year in grad school when I learned that lesson from a postdoctoral fellow we had in our research group, Dr. Palavin, and I'll be forever grateful, and I am, to Dr. Palavin who taught me that lesson. And another day, I'll tell you the story behind that, but not today. But remember, you can always ask questions. You're encouraged to ask questions. That's how you learn. And another thing, which is unfortunate, and I see a lot of students doing, you never, ever, ever have to say, sorry, or I'm sorry, but I have a question. No, ask questions. And guess what? I answer them too if I can. Now, a couple of things. I am an organic chemist. Yep. And I've worked most of my adult life, or a good part of it, in the chemical industry, where I was a senior research and development manager for a number of international chemical companies until chemistry left Chicago back about 2001. And since then, I've been teaching at Elgin Community College, and I also teach at College of DuPage. And I think I started teaching Chem 170, and I'm the only one who teaches it exclusively at ECC, Elgin Community College, since I think 2007. I've done it a few times, I guess. But organic chemistry is fun. Whatever you've heard, it's wrong, it's fun, but don't forget I'm biased because I'm an organic chemist. Now, I should warn you, I have a sense of humor and I use it. Sometimes I have good humor days, and sometimes, well, we all have to suffer through my not so good humor. But I try to limit that. All right, being an organic chemist, I like to do experiments, and I'm going to do an experiment right now. And because Zoom plays tricks on people, everybody see a white screen. And is everybody, the way I do it is I have what I call my thumbs up people. And you see me writing something. And this is a molecule. Don't write it down. You don't have to. Trust me, I'm a chemist. Did that work? But anyways, how about trust me, I'm a doctor. Does that work? But anyways, this is called propane. And I can even write it in red. I should mention, I've been teaching on Zoom now for almost 3 years, and I've got it pretty much, I can give the same experience on Zoom you would have if we were face-to-face at ECC. So propane, CH3, CH2, CH3. We'll talk more about what CNH is, in case you forgot that's carbon hydrogen later. All right, that's propane, but don't write it down. All right, now, as I said, my background, I got my bachelor's degree from Illinois Institute of Technology, see the ring, and then I went and got my PhD at Michigan State. Thank God I worked for Dr. Rouge, who was my PhD advisor, who I will forever be grateful to, because under him, I learned how to become an organic chemist. Then I was a postdoctoral fellow at University of Illinois, Chicago. Back then it was called Circle, now it isn't, until I got a full-time job. And that was with Anglo-Dutch company, AXO. And from there, I became the youngest section head of this international company in research. And I went on to other companies. I'll talk more about that another day. But I'm an organic chemist, and I love organic chemistry. It's been a major part of my life for a long, long time. If you've noticed, I'm a little older than most of you. All right. Now, a couple things I want to talk about before we go into my syllabus and everything is, first of all, I teach by my golden rule of teaching. What's that? My golden rule of teaching is I don't do to my students what I didn't like done to me when I was a student. So I don't play tricks on my tests. I hated multiple choice, SAT, ACT, not good. I did good enough to get into schools. My GREs I never sent out because I went to IIT. And at that time, it had such a great reputation. Without my GREs, that's graduate record exams. It's like the SATs, but for grad school. I got accepted to the University of Chicago, Northwestern, and a few others, but I went to Michigan State. That was a good move for me. All right. So on my test, yeah, we'll talk more about it, but I can tell you this. Every question on any test I give or the final, I've talked about that concept at least twice, usually a lot more. So there'll be anything you need to learn or know to answer questions on my test, I will teach you. All right. Another thing, we're on Zoom, I'm recording it, and within 24 hours or less, I'll post it on my YouTube channel. Do you know I'm a YouTube star? Not really, but I have a YouTube channel for Chem 170, and I also have it for general chemistry at the other school I teach, College of DuPage. I have stuff on there too, but for here, Chem 170, and today's lecture by tomorrow morning, hopefully it's later this evening, will be posted on YouTube. So you can go back and look at it, or if you can't come here for a lecture, you'll be able to see that. Now, one of the things, because I've lectured in industry, and I've also taught a long time, after about 50 minutes or so of lecture, your brain shuts down. You're sitting, your brain shuts down. So what we're going to be doing when we have the longer lectures like today, on Wednesday it's shorter, because we have a lecture in quote unquote the lab, and we'll see more about that, and not next Wednesday, but the following Wednesday. We'll take a break. If we're face to face every 50 minutes, I take a 10-minute break, but since we're on Zoom, I take a 5-minute break. That way I can get up and stretch after sitting for 50 minutes, and you can do that or whatever. All right. Any questions? Remember, if you have a question, A, turn on your microphone, or B, do the chat. Now, one bad thing, bad Dr. White, sorry, but I don't always see the chat, look down. That's a bad habit of mine on Zoom. So if you have a question, you've asked it on chat, do it again or go like this, or just turn on your mic. I have everybody's mics turned off because I learned very quickly on Zoom, if everybody's mic is turned on, background noise is just too distracting. Not that you have background noise, but there might be. All right. In that case, let's get going. Everybody see on their screen, Chem 17800, thumbs up, people. Do you see that? Thank you. All right. Now, this is D2L, otherwise known as Desire to Learn. You can log on. I think a lot of you have already done that. And here's the Chem 170 D2L. All my lecture slides are in D2L. Also, I have a lot of other things. Now, over here, I have the Zoom meeting, and I have links for that. And I'll talk more about it. But on Tuesday and Thursdays, Wednesdays, from 6 to 7:15, I will have an office hour. And to show up, it'll be on Zoom. This way you don't have to drive to ECC. If you have any questions, stop by. If you want to say hello to me, stop by. But it's there, and that's to help you if you have any questions and you don't feel comfortable asking them during our class, which some students don't. Now, if you notice here, I have content, discussion. I don't use assignments. I don't do quizzes. I'll talk more about that. There's grade. You won't see it, but I have my class list so I can send out. We click on content. You'll see over here, I have our syllabus, and I'll talk about that. Here, once again, it's in my syllabus, but we have log-on information for both the lecture. Then I have lectures. And if I click on that, you'll see Chapter 2 alkanes. Now, not all of you have MS Word, Microsoft Word. So I have everything I post in here, I post as both a Word document and a PDF file. So that way, if you want to study on your cell phone or anything else, you should be able to open up the documents. Now, I'll talk more about it, but I have practice problems. And I have the practice problem answers, where this helps you. And I'll talk more about that after we go through my syllabus. Now, I also have the address, and it's in my syllabus, or the link to my YouTube channel. And you see that handsome guy there? It's me. And I have, I think, about 3 or 4 semesters on Chem 170. So if you want to get ahead, you can go back and look at these or just stay along here. Now, one thing about the file name, if you notice, like this first one where it's 20/22/12/07, that's the date. And then that's week 16. Today, I'll post our first Zoom meeting video for today. And the next one will be, what's today's date? The 18th, 2023/01/18, CHM 170 Zoom meeting, week number 1. And that way you can find everything. Now, if you go back, really far back, like about a year ago, you'll see I have glasses. And about a year ago, November, almost about 14 months ago, I had cataract surgery, major stuff, and it worked fine. If you people need or know someone who need a good eye surgeon, Dr. Cabin in Hoffman Estates is amazing. I mean, he really is. I was lucky enough to find him. All right, so in the contents, we have various things you'll be using. They required the learning modules to set it up if we were just asynchronous. And I have here, I'll talk later in the semester, some of my favorite music, movies, and books. How many of you are familiar with Jimi Hendrix? Anybody? Oi. Oi. He's probably one of the greatest rock guitarists of all times. And my real claim to fame is when I was in high school senior year, I saw him live in Chicago in concert, the only time he ever played in Chicago. Wow, it was one of the greatest concerts I ever went to. But there's some things we'll talk about during the semester. Now, I'll be posting assignments in here. You're not going to see anything because I don't have anything, but I'll have our labs and tests and things like that. And you'll download them and upload them to this. And when it gets time, when we do our first lab and first test, I'll talk about that. One thing, if you don't have a printer, don't worry. If you don't have a scanner, let me stop. If you don't have a scanner, relax. I have files I have, and I'll send you out later, that if you have a cell phone that takes pictures, and I think most of you have access to that, you can take pictures of what you hand wrote, your lab or the answers to the test, and convert them into a PDF file that you can upload to D2L. So relax. Ooh, you know what I forgot? Propane. Propane is CH3, CH2, CH3, and today I wrote it both in black and red. By the way, my favorite color is red. Has been since I was about long enough I can remember. All right, propane, again, CH3, CH2, CH3. And in the next hour or so, I'm going to try for the Guinness Book of World Records saying propane, CH3, CH2, CH3 the most times. Well, maybe. We'll see. All right. Now, if you go to D2L, let's do that. If you click on syllabus, you'll see I have the syllabus as both a Word document you can download or a PDF, or you can open up. You don't have to even download it. Let's go through the syllabus now. This is not the most exciting thing, but it's important. All right, everybody see the syllabus on there? Thumbs up, people. Thank you. All right. I'm here. I'm Dr. White. Now, here's an office phone. I can't remember what year I last checked that. It's really a voicemail box. It's got to be at least 5 or 10 years since I've checked it. Do not contact me by office phone because I just don't check that. But my email, and this is important, kwhite@elgin.edu, I check twice a day, every day, including Saturday and Sunday. Now, my twice a day is probably different than your twice a day because I get up early all my life. I haven't had to sleep that much. So usually the first time I'll check it is between somewhere 6 and 7 a.m. And then later in the day or evening, I'll check it a second time. If you have any questions, remember in my class, there's no such thing as a dumb question. Email me or come to my office hour or ask in class. Now, obviously, we're starting today. We'll have our lecture and labs on Monday and Wednesday. This is the same time if we were face-to-face at ECC. And it's on Zoom. Here's the links. Obviously, I had it right because everybody made it here today. Yay. Now, here's my YouTube channel link in case you want to go back. Again, this you can all download. Anything I show you on a screen, you can download from a file, other than when I use my whiteboard, and there you can go back and look at the video. Oh, one thing. Remember, there's no such thing as a dumb question. in my class, in my world. And I should warn you, I have one of the fastest mouse wheel fingers this side and the other side, the Mississippi. And a good question always is, can you go back to the last slide or whatever you were showing? And the answer will always be yes. Always free to ask that. I try and give you enough time to write things down, but still, if you need to ask me to go back to something, feel free to ask. All right, like I said, the best way to reach me is by email. There's a bunch of stuff I'm required, not only I, but all faculty, to put in their syllabus, and that's this stuff right here, which we're going to skip. Now, attendance is recommended. I've been teaching now on Zoom for a couple of years now since the pandemic started. One of the things I found out is students who don't watch the YouTube or come to my lectures don't do well. Oh, I should tell you something about me personal. I'm a very selfish person in one respect. I like things happening in my life that make me happy. I don't know about you, but I do. One of the things that makes me very happy is to see students succeed. Giving an F or a D is not a joyful thing in my life. No. Giving A's and B's are. So I'm going to give you tips how to do well in my class, but you have to put in the work. I don't take the test for you. If I did, I'd get perfect score. I hope so, since I write them, but watch the videos, keep up with the practice problems, and I'll remind you that. Or come to class like you are today, and thank you. By the way, thank you for all of you for turning on your video, the ones who have, and the ones who haven't, thank you for showing up. I have this thing about behavior and about cheating. Just don't cheat, please don't. I've never really had problems, except one time a number of years ago, face-to-face, I had a couple students cheating and they found out I do what I have my syllabus. All right, preparation. I've made the textbook optional. This is the only time you'll ever see the textbook in my class. Here's the textbook. And it's not a bad textbook. You notice it's written by Hart, Crane, and Hart and Haddad. This first Hart was Dr. Harold Hart. I don't know if he's still alive or not. And he was at Michigan State when I was a grad student. And I got to know him because he was usually very aloof. And when I walked by him, or any grad student would walk by him, he'd ignore you. He was very good, outstanding organic chemist, not just for his textbook, for his research in organic chemistry. And I was taught when you walk by somebody in the morning, you say good morning. And for a whole 3 weeks, I'd walk by him because his office was not far from our lab where I was. I'd say, good morning, Dr. Hart. And finally, one day he said, good morning, back to me. And other grad students who saw that were like, wow, what did you do? And I'd always say, but he also made a ton of money from that book. The book is good, but I don't use it in my class because students have found they don't need to. My slides, my practice problems, which are much better than what are in the book, much better, which is why I had to create them, because the ones in the book were, how should I say this? Stink. But anyways, that's why I wrote the practice problems. Now, one thing you will find out after test number 1, don't tell anybody, but you'll find out why I call them practice problems. You'll know. But anyways, most of my lectures are based on what's in the book. And the way it was set up is a very good one. But I include a lot more because I have many decades experience in the chemical industry. Oh, it's time for me to show off. By the way, I have 10 US patents in organic chemistry. They're all commercialized too. All right, do not raise your hand. Do not say anything now, but talk to me or email me in private. Listen carefully. If you are a special needs student I totally support what we do at ECC for special needs students, and contact me in private or have the Learning Center ADA coordinator contact me, and I will help you out whichever your special needs are. I have when we've been face-to-face. Over the years teaching, I've had a number of special needs students. They've all done well. So if you need anything special, let me know. And again, do this in private, but if you're a special needs student, let me know. All right, let's talk about important thing to you. Don't forget, in a galaxy far, far away, long ago, I was a student too. I don't know about the galaxy part, but I still remember what's important. Tests. There are going to be 4 tests. Here are the tentative dates. The reason why I say tentative, sometimes the first test I'll change because the class could use another week of practice and everything, and I want you to do well. My fervent dream is to have a class that everybody, and listen carefully, earns an A. I've come pretty close. Usually when I teach Chem 170, I expect, now I'm being, I don't know, selfish, but I expect at least 60% of the class to earn A's. And that usually happens when I teach, and that's organic chemistry. I didn't ask, but and I haven't set it up yet. I haven't set up the poll. But for those of you who have your, let me do this. For those of you who don't have your screen, you can use the emoji. If you've heard organic chemistry is really scary and bad, give me a thumbs up. It isn't. It's fun. But that's part of the reason it's scary and bad is the way it's taught. And I know because I've had a number of students over the year who have flunked it once or twice at other schools. In fact, last fall and last summer, I had each one a student, one of them took it twice at other schools, and they both got A's with me because I know how to teach organic chemistry, because I'm teaching to help you learn it and get a good grade, not to teach it as a flunk out class, which some schools do, sad but true. All right, so there'll be 4 tests. And the way we'll do a test, and I'll talk more about it before the first test, is I will post in the assignment area the test. It will be a password protected PDF file. Oh, you know what I forgot? Propane. I've been slipping on that. Propane is still CH3, CH2, CH3, propane. By the way, propane is the gas, or actually it's going to compress the liquid in the white tanks for your barbecue, if you have a gas barbecue. All right, the way we'll do tests is I will post it in the day before, and all my tests are on Wednesday, so it gives me time to grade it. Because I don't use multiple choice, I didn't mention that. I hate multiple choice, always did. I sort of mentioned it. No tests, there are no multiple choice questions, never in Chem 170, both on my test or on the final. They're small, you write down the answer, and you'll see more during this next couple of weeks when we do practice problems. Hint, practice problems after test 1, you'll know why I call that. Well, anyways, you'll download a password protected PDF file, and on the Wednesday I give it, after class, I'll send out a pass email with the password. And you'll have 24 hours to take the test, make a PDF file of your answers. And if you don't have a scanner, I'll have a file to teach you how to do it with your cell phone and upload it. Now, if we were face-to-face, you'd have 50 minutes. And the way I write tests And again, remember my golden rule of teaching. I don't do to my students what I didn't like done to me as a student. In science and math, I was usually one of the top students, so I could always finish a test. But some teachers wrote tests, so only the top students finish. Don't do that. If we're face-to-face, if I have a 50-minute test, you usually should be done if you studied in 40 minutes. However, since we're online, what I do is I give you as much time as you need to get it done, as long as you don't cheat and go on the internet or look at your notes. And being a very clever person I am, I put things in my test that point out if somebody's cheated to me, so please don't. All right, and if there's a grading error, students should never be penalized for an error I make on a test, and I always correct those. All right, there'll be a 2-hour comprehensive final, and I have starting at 1 p.m. on May 15th. What that means is we won't have class that day. On that day at 1 o'clock, I'll send out a password in an email to you, and you'll have until the next day, 1 p.m. to take the final and upload it. And students do good on my final. Later in the semester, I'll talk about extra credit. If there's a reason for a makeup exam, I allow those for extreme emergencies. There's got to be some kind of documentation. Unfortunately, in the pandemic we've been living through the last couple of years, students have had extreme emergencies, like coming down with COVID, having family members who are sick, or having to be called into work because coworkers have COVID and they have to cover for that. So I take that into account. Now, let's look at how do you get a grade in my class? Well, you're going to have 4 tests. I take the 3 highest test scores, which would be worth each test 100 points, 300 max. The final exam is 200 points. Relax. People do good on this. People do good in my class. And that's worth 32%. Now, we're going to do some labs, and they're 11 points each. And I'll talk more about that today. And there we have 132 points. It adds up, and I made a mistake here. That should be a 2 there. Yep. Well, I don't know how I'll use this in the future a lot. I don't walk on water unless it's frozen. Even then, I stay off it. In other words, I'll make mistakes, and if I do, correct me. But first, propane. Propane is CH3, CH2, CH3. Propane. And that's the organic molecule of the material that you use for your barbecue. All right, so these are all the points you can get in my class. And you have a percentage that I calculate at the end of the semester. It's the sum of your 3 highest tests, your final exam points, your lab total. There'll be an extra credit project that's optional, times 100, divided by 632. I got it right there. And you'll see if you get 90% or greater, you get an A, 80 to 89, B, 70 79, C, 60 69, D, less than 60, L. And like I said, historically, and I expect this class should be no different, usually 60% or higher will earn, the key word is earn, an A, and some students get Bs, and there are very few at the bottom, hopefully no Ds or Fs. And I'll be sending out test grades. I'll be posting it in Blackboard. I'll also, since you're not handing in your test, I found a way a couple years ago that I send out individual emails that has how many points for each answer. And every test, after I hand it back, I go through the whole test with the correct answer so you can see what you got wrong and learn from that. In terms of withdrawal policy, you have to do that through the registrations, not handing in labs, not coming to class, not taking tests. Doesn't officially withdraw you. Incomplete, if you have a problem, I give incompletes. Again, this is not the most exciting thing, but this is important. We'll get to some good stuff later on. Oh, good stuff. Propane, CH3, CH2, CH3, propane. Everybody look at the screen. That's propane. All right, everybody see tentative course outline on the screen? Thumbs up, people. Thank you. All right, here's the schedule. I try and keep to it. Here's the test. One of the things I do, all my tests are on Wednesdays. The Monday before, I do an hour review of all the material that will be on the test. And that helps students. They said it did, and so I keep on doing that. Oh, one thing, if there's anything I should ever do to help you learn this better, let me know. And here's the outline for the whole semester. And if you notice in week 17, that whole week, 4 hours, or a little more even, because we don't have a lab, I will do a review of the whole semester. And that's also why my students do good on my final, because if you come to the Zoom meeting or watch the videos, you get a whole 4 hours of review for the final. All right. How are we doing time-wise? Doing good. And it's time for propane again. You'll be sick of me saying this, but I'm going to show you later on why am I doing this. Propane, CH3, CH2, CH3. Propane, that's stuff for your barbecue. Actually, let's do this. Next thing I'd like to talk about is lab. Now, in 2007, I inherited Chem 170 from a faculty member, adjunct. Most of the faculty members at ECC are adjunct part-time, because that way they don't have to pay us as much as full-time. It's true, but anyways, and the labs they used were awful. Actually, beyond awful. They were awful, awful. Oh, that reminds me. When I was at one company, we hired a summer intern, and she was probably the most sweetest, nicest person I've ever met in my life. And when she'd get mad, she'd say, "That's awful." And that's all she would say if she was really mad. Now, if she was really, really mad and you knew she was mad, she'd say, "That's awful, awful." But anyways, the labs were awful, awful. Having worked many decades, yes, decades in the chemical industry, I challenged myself, could I write labs that we could do that the students would like and learn from? And I did. If we were face-to-face, we'd be doing in the lab. Since you're not, and you can't really do organic chemistry at home, I have the same labs. I've done the data is in there, but it's the same mental exercise. So that's our labs, and those will always be on Wednesday. And if you see here, there's no lab manual. So I'm saving you a lot of money. You don't have to buy the book. You don't have to buy a lab manual or a chemical kit. Now, I'll be doing it here. There's going to be 13 labs, and I'll drop the lowest one. I'll take the 12 top scores, and that will be, each lab is worth 11 points. Now, lab reports are due the next lab session after the session, the lab report being handed in. So we're not having one today, but if we were having a lab today on Wednesday, I would say, here's the lab, we go through that. You download it from D2L, write in your answers. If you don't have a printer, just write your answers on a piece of paper. And that reminds me, I keep on forgetting, it's a generation gap thing. I'll ask in a question in a little while. And then you'll hand it in the following Wednesday or by the following Wednesday. And you do, if you don't hand it in late on time, it's late, you'll lose 2 points. If it's really late, you get 0 points. The reason I put that in, the last week of class, I don't need a number of students to hand in labs where I have 30, 40 labs to hand in. The first time I taught Chem 170, that actually happened. I said, that's never going to happen again. So handing things on time, my labs to a lab report shouldn't take you more than 30 minutes, probably less. And here's the tentative. Today, we won't have a lab. If we were at ECC, we wouldn't. Next week, we would have done safety, which we don't have to do online. So that's why I'll do lecture. And on the third week, and this is that Wednesday, we'll do the melting points. And that's that. And propane. Propane is still CH3, CH2, CH3. It's got 3 carbons. Remember, C is carbon, H is hydrogen. But I'll remind you about that later on. And that's the gas that you use to cook with if you have a barbecue. Now, if you work at an industrial site, that inside they use that for heating areas. Now, at the very end, you'll see what I call the student agreement. And this is something, don't use this one. There's one in D2L, I'll show you that in a second. Essentially, it says you've read the syllabus and understand the policies, and you'll abide by those policies, and you understand that failure to abide by those policies will result in the consequences outlined in the syllabus. In other words, you understand I will do what's in my syllabus. Hopefully that will never happen. Those sort of things. Also, because of FERPA, which is a federal, whatever law that is privacy for students, you waive those rights. So I can videotape this and post this on YouTube. By the way, I think the highest number of views was last October 31st, Halloween. I had like 80 because people told about the wild thing. Go back and look at it. You'll see Dr. White was a wild and crazy guy for Halloween. But anyways, this is in. If you look here, the signature sheet, let me open it up, and here's the PDF. And you print your name, sign it and date it, and upload it. I'll set it up in today or tomorrow, probably tomorrow or Friday, in the assignment area of D2L. And you notice in blue, I need to have this signed before test number 1. If I don't, you'll get a 0 for test number 1. In other words, everybody, you got plenty of time. Test number 1 is until a couple weeks from now, February 8th. So you got plenty of time. All right, any questions? Like I said, that's not the most exciting thing to go through. How many of you ever seen the Blues Brothers movie? Oh my gosh, you people are missing all the good things in life. But anyways, Going through a syllabus is like going into a 4-star restaurant or 5-star restaurant and ordering plain white toast. It's important, it'll keep you alive, but there's so many better things to do. All right. Propane, CH3, CH2, CH3. Propane. Now, I could have done it a couple more times, but everybody, close your eyes. And can you picture propane? Can you see in red the CH3, CH2, CH3? You can open your eyes now. Hopefully nobody's driving. I had one student one semester who would listen to me on their cell phone driving into work. So I have to be careful when I say close your eyes. But anyways, the reason I did that is, and I'm not going to sugarcoat it, organic chemistry, there's a lot of memorization. It's just part of organic chemistry. Now, you can use flashcards, and for me personally, and most students, they're very ineffective. But the way I learned it, I can't remember when I learned this, and I share it with my students. If you write something down and say it 5 times, it burns it into your brain. If you do it a second time, it really burns it into your brain. And what do I mean by that? If you want to learn the structure of propane, write it and say propane, CH3, CH2, CH3, propane. Do it again. Propane. CH3, CH2, CH3, propane. And you got to both write it, that's the visual part, and say it, that's the audio part of it. And if you're in a library, you can just say it silently in your mind. If you do another one, CH3, CH2, CH3, propane. And you do that 5 times, you come back a day or 2 later and do it a couple more times, 5 if you want. It's going to be in your brain. Why am I teaching you this? One semester, and I can still remember, I have a photographic memory. I can close my eyes, I can still remember those 2 students. I had 2 students who were very close friends in my Chem 170. And after test 1, they both came up to me, and one of them said, I didn't do that well on test number 1. How can I do better? I said, did you write things down 5 times and say them? I can still remember, she said, no, that's a lot of work. And her friend who was standing right next to her said, yeah, but I got an A on the test. And the first student got the message. She did that and did much, much better on the next test. It's a good way of memorizing things. And you'll be memorizing a lot. That's just part of organic chemistry. Now, if I look at the clock, it's time for a 5-minute break. I'm going to take a 5-minute break, get up and stretch. And I'll see you in 5 minutes at 1:55 by my clock. So I'll see you in 5. Time to get going. And for those of you turning on your camera, thank you. I've got to find a cartoon. Let's see if I can find it real quick. Nope, I can't. Next Monday, I'll find a cute cartoon about teaching on Zoom. A friend of mine's wife sent me, who's a teacher. But anyways, all right. First of all, I'm going to assume, even though you really shouldn't assume, one of the greatest mentors in my life, Sid Shapiro, when I started in chemical industry, Sid was my mentor, always taught me common sense is not common. But I'm going to say, and also you should never assume because you become the first three letters. But anyways, and I found out in life that's always true, both of those. I'm going to assume all of you want to get a good grade in my class. If you get a good grade in my class, I also get what I want. You've learned organic chemistry. Well, how can you get a good grade in my class? Well, besides do the practice problems, let's talk about bicycles. Bicycles? Well, let's assume you don't know how to ride a bicycle. And being the nice person I am, I get you the best and send it to you, the best Blu-ray disc on how to ride a bicycle. And you watch that Blu-ray for the next 8 weeks on your big screen TV, and you watch it and you got your remote control and you do it backward and forward, slow motion, frame by frame. So after about 8 weeks, you know that Blu-ray by heart. But you still don't know how to ride a bicycle. What's going to happen the first time you get on a bicycle? You're going to fall off. Organic chemistry is no different. You can watch me do problems and other things we'll do in this class. And if you don't do the practice problems, guess what's going to happen on the test? You're going to fall off, and that won't be pretty or fun. And I don't want to see that. So just like with the Blu-ray or learning how to ride a bicycle, you got to actually get on a bicycle and learn how to ride it and get that experience. You have to do the same thing in my class, do the practice problems. All right. Oh, one other thing. I'll probably do it next Monday or next Wednesday would be better. And I'll put out an email because I'm going to cut it out of the video. I'd like my special effects here. Cut it out of the video. I told you I have a sense of humor and I use it, but that was pretty awful. But anyways, years ago, I came up with a method based on some book I read on how to eliminate test anxiety. And over the years, a number of students have that. They study hard, do all the practice problems. They start taking a test and they get so anxious, their brain goes, just doesn't work right. And I have a method that eliminates it like that. And you can use it for other classes too, not just chemistry. And last semester, I had a student like this, and also last summer, and the first test, they barely got a C or B. They learned how to eliminate test anxiety, and they got A's. I've had, when I've taught face-to-face, I've had students who barely passed tests with a D, learn the method, eliminate test anxiety, and go to get some of the highest scores on tests in my class. And guess what? Same thing happened in other classes. So I'll teach that. And let me put it down a little note. A week from today. And I've never come up with a good name for it. I just call it the method. And interesting side story, the person who developed the method, what I modified, Dr. Jeannie Laborde, I called her up, and she's got a great book. It's called Influencing with Integrity. And I told her about it, and she said, that won't work. You can't do that to my method. It's not going to work. Because I streamlined it. When I teach you about the method, I'll teach you the first time how I came up with it. It's interesting, a touching story. And about a month later, she calls me back and says, I have to apologize to you. I said, for what? And she said, guess what? Your method works better than I have. And I have, and she did too. I've actually taught it to 10-year-olds to help them when parents have heard about what I do, and it's really worked well. All right, I'll do that a week from this Wednesday. All right, let's go through some basics. I'm going to assume, but I don't, so that's why I'm going through it. You know some of the basics. Oh, there's propane. It's still CH3, CH2, CH3. A year from now, if you see me and it's happened, I'll ask you, remember what I did the first day of class and wrote on the screen a lot? And students immediately will say propane, but it's still burned in their brain. Sorry about that. All right, let's talk about things. I'm going to assume you know what an atom is, and I'll never ask on a test, what is an atom? And an atom is the smallest particle of an element that has all the properties of an element. I'm going to assume you know what a molecule is. Oh, couple things. How many of you, give me a thumbs up, cannot read cursive? Like if I were to do this. Even though I haven't done cursive on other classes, I've had students, nobody could read cursive. I'll print. And if I print something you can't read, remember, there's no such thing as a dumb question in my class. You can ask, what the heck was that you just wrote? But anyways, you should know that a molecule are atoms held together by chemical forces called the chemical bond. And that I'll never ask on a test. But I'm going through some of the basics you should know. Now, when we talk about chemical bonds, and remember, you can always ask questions. There are two types, ionic and covalent. And ionic is, and I won't ask this on a test, is by transfer one or more electrons from one atom to another atom. Covalent is sharing pairs of electrons. And if we were in class at ECC right now, you would be watching me write this on the whiteboard. And a covalent chemical bond is sharing pairs, remember, pair means two, of electrons between atoms. And most of the chemical bonds, not all of them in organic chemistry, are covalent. But there are some ionic. We'll get to the middle of the semester. Boy, it's going to be such a fun semester. Oh, I forgot to mention this. One of the exciting things about this semester is you'll learn that my world of organic chemistry is really your world of organic chemistry, and you just don't know about it. And we'll do a lot of things in the real world. Oh, I forgot an important thing. Another thing. It happens the first day. Why should you learn organic chemistry? Good question. Thank you. Let's think about that. What's organic chemistry? Well, my shirt is organic chemistry. The molecules, my top here is organic chemistry. The hair I have left in my beard is organic chemistry molecules. So is my skin, my muscles. Yes, I still work out with weights. And let's see, your food is organic chemistry. Those are organic molecules. And All the medicine you need is organic molecules. So let's think about it. Why is it important that you learn organic chemistry? Oh, I forgot to ask another question. Before I answer that, how many of you are taking organic chemistry because somebody said you needed this to get into school or program? Give me a thumbs up. I see a lot of thumbs up. How many of you are taking organic chemistry because you have an undying love of organic chemistry, near and dear to my heart? Nobody. So you're taking it because somebody said. Well, why is it important? Well, let's see. Your food is organic chemistry. Your body mostly is organic chemistry. Your clothing is, everything about you. So isn't it obvious why it's important that you learn organic chemistry? Somebody said you have to take it and you want to get a good grade so you can get into a program like nursing or other things like a physician's assistant, etc. I know that. Now, you know, I know that. So I'm not going to try and teach you to be an organic chemist, but I will teach you organic chemistry. Tea break time. So anyways, that's why it's important to learn organic chemistry. And most of the, like I said, the chemical bonds, most of those are covalent. And we'll talk about this. Now, I'm going to assume you know certain chemical symbols. Let's go through the important chemical symbols that you should know from the periodic table. I'll never ask this on a test, but I'll use them. The most important: hydrogen, carbon, then some of the alkali metals, lithium, sodium, potassium, alkaline earth, magnesium and calcium, carbon, and then nitrogen, oxygen, sulfur, the halogens, chlorine, bromine. Well, I forgot fluorine on top here, and iodine, and a couple of metals, nickel, platinum, and palladium. And in real life, that's my periodic table. And you should know H is hydrogen. I'll never ask that on a test. C is carbon. Let me clean this up. N is nitrogen, O is oxygen, S is sulfur, F is fluorine, chlorine, Cl, bromine, Br, iodine. And that's all you need to know. I'll never ask it also nickel, platinum, and palladium. Now, gold is nice and silver is nice, but we really don't use that in this class. Now, if you want to send a couple of pounds of gold or palladium or platinum to me, you can, but you don't have to. All right, so that's the periodic table: hydrogen, lithium, sodium, potassium, magnesium, calcium, carbon, nitrogen, oxygen, sulfur, fluorine, chlorine, bromine, iodine, nickel, platinum, and palladium. And I will never ask that on test, but example, you should know the C's there are carbons, the H's are hydrogens. By the way, this is butane. And it's an organic molecule. And that's the liquid in those small, cheap lighters, butane, which is why they're called butane lighters. All right, so this is my periodic table. Now, it turns out the way organic chemistry has been taught and also segregated, the key parts are by functional groups. If you notice right there, that's a door, and you go from one room to the other. And if you were to come to my home, you'd see my front door doesn't look like that, but you know what a door is, so you know how to use it to get in. If you were to go to ECC, they'd be different doors, but they have the same function. Organic chemistry is divided into what's called functional groups. Combination of atoms in a molecule, no matter what molecule those combinations are, those functional groups have similar chemistry and similar nomenclature. By the way, nomenclature is the fancy word for naming. You're going to learn a lot of neat words and stuff in my class to impress your loved ones, neighbors, and friends, if you want to. All right. Sometimes people don't want to hear organic chemistry. I don't know why, but they just don't. All right. So we'll be going through functional groups this semester, and I'll be teaching you. The way we'll do it is I'll introduce you to a functional group. We'll talk about how do you name it, how do you make it, then the fun part, how do you react to make things? And we'll do that. Let me close a few things that I don't need right now. All right, everybody see chapter 2 on your screen right now. Thank you. All right, it's time to start your journey and learning about my world of organic chemistry, which is your world. Now, once in a while, I will be very subtle. And there's some definitions I'll ask you to learn. And the first one is when we talk about organic chemistry, let's talk about hydrocarbons. And what do I mean by subtle? I don't always do this, but is that subtle or not? Yeah, you should know this. And the first thing is, what's a hydrocarbon? That's a molecule with only carbon and hydrogen atoms. So when they talk about hydrocarbon pollution in our daily life, unfortunately, they're talking about molecules that have only carbon and hydrogen. And propane is a hydrocarbon. If you look at this molecule right here, there are only carbons and hydrogens. And that's a hydrocarbon. So if I were asked on a test 3 points, what is a hydrocarbon? The answer would be molecules with only carbon and hydrogen atoms. Now, let me remind you, there's no such thing as a dumb question in my class. If you ever have questions, ask. And also, don't forget, I have the fastest mouse wheel finger this side or the other side of the Mississippi River. So if I move a slide too quickly, feel free. Could you move back to that slide? Now, when we talk about hydrocarbons, there's 2 types of hydrocarbons. And everything you see on the screen right now, other than when I write on there, is in the file in D2L, the lectures, secretly named Chapter 2 Alkanes. And since I should be subtle again, I will. Don't you like how I can be subtle? And by now you should have guessed my favorite color is red. When I write something in red, that means it's really important. So what do I mean, know this? Well, there are 2 types of hydrocarbons, saturated hydrocarbons and unsaturated hydrocarbons. What is a saturated hydrocarbon? That's a molecule with only carbon, hydrogen atoms, which all carbon-carbon bonds are single bonds. So a saturated hydrocarbon is a molecule with only carbon and hydrogen atoms, in which all carbon-carbon bonds are single bonds. Now, unsaturated hydrocarbons are molecules with only carbon and hydrogen atoms. That's a hydrocarbon. But the unsaturated part tells you that contains one or more carbon-carbon multiple bonds called a double bond or triple bond. Again, saturated hydrocarbon, molecule with only carbon and hydrogen atoms, only carbon-carbon single bonds, and unsaturated hydrocarbons, which you should know, are molecules with only carbon and hydrogen atoms that contain one or more carbon-carbon multiple bonds, or you could have written a molecule with only carbon and hydrogen atoms that contain a double or triple bond. Either one of those ways would work for me. Oh, by the way, did I tell you I'm this close to the person who's grading the test and final? Me. So when I tell you this is acceptable, guess what it is? Plus, it's being recorded now. If we were in class, I'd say to students, and you have the people around you as witness, I said that. That's true here too. Now, I'll wait a second or two, make sure everybody's done copying if they want to. Oh, tonight at midnight, I'll be giving speed note-taking lessons. No, I won't. All right, let me just remind you. And this will never be on a test, but I talk about it, so you should know. Actually, you should know this. Oops. All right, there are three types of covalent bonds in chemistry: a single bond, double bond, triple bond. And this I'll never ask. Well, I can ask how many pairs of electrons. We'll talk more about it when we get into double bonds, not this chapter, but the next chapter. And a single bond involves one pair of electrons. A double bond, two pair, and triple bond, three pair. For those of you who know baseball, when you get a single, you go to first base. When you get a double, you go to second base. And when you get a triple, you go to third base. But I think you should know this, that the three types, single bond, double bond, triple bond. A single bond has one pair of electrons, double bond, two pair, triple bond, three pair. And we'll talk more about it this semester. And I'll give away something up front. How many of you have ever seen a carrot? And you know what color a carrot is? That's due to a molecule with double bonds, organic chemistry. So why you learn, oh my gosh, carrots, that's organic chemistry, the color of carrots? It is. Isn't this getting scary? It shouldn't be. I told you organic chemistry is everywhere, and you'll find out this semester. That's part of the, how should I say, benefit you have of having someone who has worked in the real world and knows the real world of organic chemistry. All right. Again, a hydrocarbon that you should know is a molecule with only carbon and hydrogen atoms. You'll find out this semester repetition is good for you to learn and good for your grade, which I think most of you want a good grade. You should know a hydrocarbon are molecules with only carbon and hydrogen atoms. There are two types of hydrocarbons. One is saturated. That's a molecule with only carbon and hydrogen atoms, and carbon-carbon bonds are single bonds. So saturated hydrocarbon has only carbon-carbon single bonds and only has carbon and hydrogen atoms. And unsaturated hydrocarbon is a molecule with only carbon and hydrogen atoms that contain one or more double or triple bond, which we can also call multiple bonds. I'll teach you later in the semester, and I should warn you, we're going to get into stuff that I am taking no moralistic view of. I'm just dealing with the organic chemistry of molecules. And birth control pills, the key chemical in a birth control pill that make them work is a molecule with a triple bond, organic molecule. It's not unsaturated hydrocarbon, but it still has a triple bond. And we'll learn that that's way in about week 15 or 16. I get into a lot of things you'd never think I'd get into. He's talking about that, and the answer is yes. All right, let's move on. Now, when we talk about hydrocarbons, there's a group called the alkanes. Now, before you write everything down, have everybody's attention. Every once in a while, I'll do this, click, the switch is off. This will not be on the test or a final, but it's something I'll use the terminology. Now, alkanes. What is an alkane? It's an acyclic saturated hydrocarbon. Oh, I know what a saturated hydrocarbon is. That's a molecule with only carbon hydrogen atoms and only carbon-carbon single bonds. What's this acyclic? Well, cyclic, bicycle, like two rings. Cyclic means a ring. The prefix A means without. So this is without any rings, and we'll talk about rings in organic chemistry. That's the fun part. Dr. White loves rings. Oh, I'll talk about this more throughout the semester. But does everybody know who's one of the greatest of all organic chemists? Mother Nature. Hands down, Mother Nature is one of the greatest organic chemists. All you have to do is look out your window, look at trees, look at grass, look at the food you eat, look at the way your body works. That's all organic chemistry. Oh, I'm going to scare you later in the semester. But in your stomach and other parts of your body, you're a walking organic chemistry plant. And your body is using organic chemistry, the stuff I'm going to be teaching you, to do things with. And later in the semester, near the, I don't know, week 14 or so, once we learn the basics, I'll go through the three main food groups and teach you how your body breaks those down: carbohydrates, fats and oils, and protein. I should mention one company I worked for, an international company, I was in charge of all their research and quality control in North America, made fats and oils. We'll get into that later on. So this is an alkane. It's a saturated hydrocarbon that's not in a ring. Now, again, switches off, but the reason I'm bringing this next one, I've been told on some of the nursing exam tests they'll ask a stupid question, which I think is a stupid question. What's the formula of an alkane? CnH2n plus 2. And it has what's called a tetrahedral geometry, which I will never ask on a test. Now here I have a molecule, a picture of this. And by the way, this is called methane. I'll teach you later on how to learn how to. Methane is CH4, 4 hydrogens, 1 carbon. I'm going to assume you know how to read a formula. And here's a hydrogen, here's a hydrogen, here's a hydrogen. And again, switches off, click, and here's a carbon. And these rods are a single bond, covalent bond, a pair of electrons being shared. And this is methane. Ooh, time to teach you the real world again. You know where you find methane? It's also called natural gas. Methane is the molecule you burn to cook with and to heat your house with, or a condo or apartment building. And it's also used for your water heater. Most people have a gas water heater in their house or home, condo, or apartment that you rent. Why, this organic chemistry is everywhere. It's getting serious. Now, we won't need it, but I'll show you some things. Here's a model like the one you saw. And if each side was a wall, this shape is called tetrahedron. Again, click, switches off. And this tetrahedron shape and other things, are you ready for this? Play a role in shaping your DNA. Ooh, now it's really getting scary. Again, alkane, acyclic saturated hydrocarbon. I'll use the term alkane, but I'll never ask on a test. Now, like I said, I was told on nursing exams, they ask if an alkane has 5 carbons, how many hydrogens? Well, if N is 5, 2 times 5 is 10 plus 2 is 12. The answer would be 12. I will never, ever ask that kind of question. Nope, I can do better. Well, let's just see if I'm telling you the truth about that formula. Here's propane, and it has 3 carbons, and 3 plus 2 is 5, plus 3 is 8 hydrogens. Ooh, that reminds me, I got to talk about the math component of this class. I forgot. Wait. Well, anyways, if N is 3, 2 times 3 plus 2 equals 8, and the formula is true. But I'll never ask it on a test. I just remember I forgot to talk about the math. First of all, on my test and exam, you are not allowed to use a calculator. No, can't use it. The math you need to know for my class, you have to know how to add and subtract up to 4. For the first 12 weeks, you have to know how to count up to 10. You have to know what numbers are bigger and smaller from 1 to 10, like 5 is bigger than 4, 3 is smaller than 7. Now, later in the semester, it gets harder. You have to know how to count up to 20. That's the whole math for this class. So you can all just say, when I was an undergrad, because I thought it was fun, I learned math through partial differential equations. As an organic chemist, I've never used those again. I never used algebra again. Well, algebra, not really. This multiplication, division, and subtraction. But we won't even do that. we use multiplication, division, and addition, a little higher level math, is if you write the procedures, also known as recipes for chemical reactions, how much of this chemical and this chemical do you need to make this chemical so much, then you need to know that math. But we don't do that in this class. I should mention a little background. How many of you are familiar with a tank wagon? The vehicle that delivers gasoline to gas stations? Hold on, let's go out to the internet. You see it on your screen right now? This right here. Let me move this out of the way. This is a tank wagon. They're standardized. They're 5,000 gallons, 40,000 pounds. I have written procedures at one plant where we did about 160,000 pounds, the reaction. That's 4 of those. That's when you're having a good time. It's exciting as heck. You're dealing with about $160,000 in chemicals, plus another 20, 30,000 in labor. You don't make mistakes, but you don't have to do that in my class. So remember, the math in my class is going to be really hard. You have to know how to add and subtract up to 4. Hold on, let me fix that finger. Up to 4. And you have to know how to count first part of the semester up to 10, and later on it gets real hard up to 20. And you have to know which numbers for now, from 1 to 10 are larger and smaller than other ones. So that's the only math we're going to do this semester. All right, so alkanes are acyclic saturated hydrocarbons. Some alkanes, you don't have to write this down right now. CH4 is methane. CH3 is ethane. And ethane, how many of you ever seen at a sports event or something, like a basketball game, and one of the athletes twists their ankle or something like that, and the trainer has this little cylinder and he sprays something on there, all of a sudden the athlete is feeling better. Usually that's ethane, and it's a liquid and evaporates very quickly. And that's what cools down the athlete's ankle or wherever. Ethane is also used to, vegetables give them off to ripen. And it's also used a few other things, but, oh, look, it's your old friend propane. You know about propane, CH3, CH2, CH3, and that's used in barbecues. So here's some of the alkanes. And we'll learn later how to name these today and next week. So you don't really have to write down this slide at this point unless you want to. And don't forget, this is all in D2L. Now, I should mention something real quick. I also teach at this semester, and I have for a number of years at College of DuPage. And our computer system is called Desire to Learn, D2L. Theirs is called Blackboard. And at both schools, sometimes I forget. And I'll say, oh, you can find us at Blackboard. And you'll look at me like, what are you talking about? Then all of a sudden dawned on me, nope, I'm at ECC, it's D2L. And when I'm at the other school, I'll say D2L, and they'll look at me and I'll remember, nope, wrong one. All right, let's continue on. Now, there's another class of alkanes called the cycloalkanes. And again, switches off, but I'm going to use this terminology. And cycloalkanes are saturated hydrocarbons. That means they only have carbon and hydrogen atoms and only carbon-carbon single bonds, but they're cyclic. They're in a ring. Bear with me while I get some more models out. I just looked at the clock. Time flies when you're having fun with Dr. White and organic chemistry. Now here's a molecule, and each center is a carbon. It's got 1, 2, 3, 4, 5, 6. The silver rods are hydrogens. This you'll learn later on is called hexane. It's not in a ring, it's an alkane. Now, if I connect the ends together, we call this a ring. It's got still 6 carbons, and this is a cycloalkane. And I should mention, Dr. White and Mother Nature love rings. I really do. And you'll learn more about rings. We're not going to use models in this class, so you can sigh of relief, but they're fun to play with. When I was in grad school, my advisor, Dr. Roosh, they were called Drying models, and each atom, they were small. You could take a ruler and build a structure, and that would be how many angstroms the length of the bond is if you measured it and did the conversion. And this is back, I hate to say this, back in the 70s, 1970s. Now you know how old I am. But anyways, each one of those were like $50 a piece, each carbon atom. And if you borrowed his set, every time he'd look at you and say, be really careful with my set and don't break anything. And you were, but they are really useful. So this is a cyclohexane. That's the name of this molecule. We'll learn later on next week or so, but it's a ring. When carbons are connected together in a cyclic form, we call that a ring. Now, you'll learn way later in the semester, your hormones, otherwise known as steroids, all contain 3 6-membered rings and a 5-membered ring hooked together. And I'll teach you about that. You're going to get into that? I will. So if you think about why am I learning organic chemistry? Well, your hormones are organic chemistry. So I will never ask on a test, but I was told on one test, entrance exam for nursing or something else, they asked if you had a cycloalkane with 6 carbons, how many hydrogen? Well, here's the formula. I'll never, ever, ever ask on a test or a final this question, but other people do, so you can. And not all rings are planar. Again, this whole slide, click, the switch is off. It won't be on a test or anything, but we'll talk more about it. Speaking about nursing and everything, listen carefully. Students who get a high B or an A in my class, and don't get me mad at them, and I've had unfortunately 1 or 2 students who have done that, which is not smart. They weren't. In that way, if you get a high B or an A, and I get to know you a little through Zoom, and I do that with most of my students, I write letters of recommendation. For a number of years now, I've been teaching Chem 170, and I can tell you this, all the major nursing schools in the Chicagoland area know me because I have students and I always send them my best. I know how to write good letters of recommendation. And I've had the faculty at UIC Nursing Chicago and Loyola and a few other schools contact me. Can you send us more of your students? Because I am quite honest about my letters, and my students are quite good. And they've also learned how to learn things by practice. So, and the other thing is, don't tell them, most of those people, the nurses who run those are faculty there. Organic chemistry, that's the hardest thing in the world. And this person got a high B or an A. They must be really smart. Don't tell them it's really easy, organic chemistry, when you take it with me. But you got to get a high B or an A. Because if you get anything lower, I can't write a good letter recommendation, I'll be honest with you. But when you get a letter recommendation from an organic chemist, those schools go berserk. Oh, we want that person. Don't tell anybody I gave away that secret. All right. Now, one of the most important things you're going to need to know is how to draw organic molecules in this class. Click, switches on. This is stuff you should know. Now, there's something called condensed structures, and I won't ask the names of that. And this shows how the atoms are connected, what do not show, or sometimes it even does, and I do it, and I'll explain why. Carbon, hydrogen, or carbon, carbon single bonds. So let's look at, and I'll never ask on a test, what's a condensed structure? You can tell I'm rusty on Zoom because now let's look at this molecule. Oh, did I tell you about the 10-second rule? Give me 10 seconds before you start writing down what I write, because I may change my mind because I'm doing all this on the fly. This is called the empirical formula, and it's totally useless in organic chemistry. Now, something you should know, this will never be on a test. This is the Lewis structure. For carbon. And again, here now the switch is off, and Lewis structure shows valence electrons. Those are the outermost electrons and the most exciting ones, because those are involved in making chemical bonds. Carbon has 4, and I hope you remember the octet rule. Which all atoms want to have 8 valence electrons. Well, if carbon has 4, how many more electrons does it need to get to 8? 4. So this is something you should know. In fact, when I was in school, if something was important, real important, in the left margin, I put a couple of stars, and it was critically important, I'd also write IMP with an arrow, so I'd know to know this. Carbon always has 4 bonds. There's always 4 bonds to carbon. This is going to be one of your friends on test 1, 2, 3, 4 in the final. Anything you write down, if a carbon doesn't have 4 bonds to it, it's going to be wrong. Carbon, how many bonds to it? 4. 1, 2, 3, 4. By the way, I'm ambidextrous. I can do things with both my right and left hand. I learned how to throw a boomerang with my left hand before I could do it with my right hand. Don't ask me why I learned how to do that, but I did. There's always 4. Oops, I gotta get that finger fixed one of these days. 4 bonds to carbon, and that's always going to be your friend. Now, as I look at the clock, wow, it's already time for a break. Let's take a 5-minute break. I'll see you in 5 minutes. Time to get going. I collect whistles, among other things. Oh, let's do a different get going one. That's another one of my hobbies, model railroading. I told you you'd learn a lot about me. All right, let's get going. And let me remind you on an important note. In my class, in my world, there's no such thing as a dumb question. Always feel free to ask questions in my class. And unlike other classes, other teachers, you never, ever have to say, I'm sorry for asking a question, because they're encouraged. Now, do I know the answers to all questions? No. By the way, don't ask me what's the meaning of life. I'm still trying to figure that one out. But when it comes to organic chemistry, if I don't know it, I can find it out. And I forgot while we were taking a break, we're talking about alkanes, saturated hydrocarbons. Next time you drive by a gas station, think about 50% approximately of the weight of the gasoline they're selling are alkanes. And one of the things I'll be doing this semester is asking for you to think about organic chemistry. We're not in a lecture, and it won't hurt, because organic chemistry is everywhere. I stole that from SpongeBob. And it won't hurt for you to think about it. So next time you drive by a gas station, think about the gasoline. A major component of that gasoline is alkanes. Speaking about that, time for a public service announcement from me, Dr. White. At one company I worked at, we sold additives to the gasoline companies, petroleum companies like Shell, Mobil. Back then it was called Standard. What is it called now? I can't think of it right now. I got a brain freeze. But it'll come back to me. All right, does everybody see? It should have it here. BP. Standard is now called BP. First of all, can you see gas buddy on your screen right now? Thumbs up, people. Thank you. If you don't know about this, is a great site. You put in the zip code. Let's see. And you notice this is for Elgin area. It has different gas stations and their prices. And it's amazing. You can go 4 or 5 miles or less from one gas station to another, and the gas price might be 30 cents a gallon different. So this is a great thing. But the reason I'm showing you this is, one, I use it all the time. And when I would go to ECC, I would usually go to, where is it? The Shell on McLean. I don't see it right now, but it's here somewhere. And you can see the different prices. Or I live in the Schaumburg area. I look at mine, and when I go up face to face at COD in Glen Ellen, and it's amazing how different the prices were. But the reason I'm telling you this in a public service announcement is because as part of my job was to go to our customers, and I was one of the few PhD research chemists marketing and sales would take to customers, because I knew how to talk to customers and help sell the product. And I went to the research centers for Shell, BP, and Mobil. And in that industry, the best gasoline is Shell for decades now. It's just the best. Right below it, and almost as good, is Mobil. The worst, and it's been this way for decades, is now called BP Standard. It used to be. Unless it's an emergency, don't buy their gas. And I'll give you a quick story. About 7, 8 years ago, in the Southern Illinois Indianapolis area here in Indiana. A refinery for BP made gasoline and got shipped to the gas stations in that area. That was so bad that it, are you listening? It destroyed the car engines of about 4,000 cars. And they had to pay to get that repaired. I don't want to buy that gas and spin that way. Now, when you look at the gas they sell, there are three different what's called octane numbers, and I'll teach you about how that came about. And for unless you have a Lamborghini or Maserati or Ferrari, which maybe someday I'll get, but I don't today. I've been in them, but not owned one. The lowest quality gas is good for you. Again, Shell, Mobil, and those are the two best. And I have an older car, SUV. You know how when you have to go in and get your cars tested for emissions? What I do is about 2 weeks before I have to go, I'm going to go in. I let the gas tank run down to empty. I usually never let it go down lower. And I'll fill it up with the highest grade. And the reason you're paying a lot of money for the highest grade is they have the most and best additive packages that helps your engine. Now, usually twice a year, I'll let it go down if I'm not going in, maybe 3 times, and I'll fill it up with the highest grade, most expensive gasoline, Shell or Mobil, and that helps keep your engine clean. And I've been doing that for many, many years. So that's my public service announcement for you. All right, let's get back to how do you draw. Remember, there's always 4 bonds to carbon. Now let's look at propane. Now I'm going to show the bonds right now. Each line in organic chemistry is a bond, a pair of electrons. That you should know. Now, this is propane. Notice it has 3 carbons. And if we look at each carbon, let's look at this first carbon right here. How many bonds to it? Let's count. Remember, you got to know how to count up to 4. 1, 2, 3, 4. So that carbon has 4 bonds to it. If we look at this carbon, there's 1, 2, 3, 4. 4 bonds to that carbon. And if we look at this last carbon, there's 1, 2, 3, 4. So each one of those carbons has 4 bonds. Remember, that's your friend. How many bonds to carbon? 4. In the next 2 or 3 weeks, I'm going to be brainwashing you that. So you'll be waking up in the middle of the night hearing me say, how many bonds to carbon? 4. It will help you. Now, this is called the expanded view or structure of propane. I'll write it again down here. And this is one of the rarest times you'll see me doing this, because it takes a lot of extra work. And you'll learn, I'll have to tell you this, organic chemists are lazy. If there's an easy way to do it, we'll do that. And here's the easier way. Now, if you look at this first carbon, how many hydrogens are there? 1, 2, 3. So the first carbon, you put to the right 3 hydrogens. Now, if we look at the middle carbon, how many hydrogens? 1, 2. Now, you don't have to put a line. I do, because if I don't, my structures start drooping toward the floor. It happens on a whiteboard in classroom 2, and on this too. So this has a carbon. How many hydrogens? 1, 2. So I'll put an H, and I'll do that. And finally, the last carbon. How many hydrogens? 1, 2, 3. And that's how you get the condensed form. These 3 hydrogens plus this bond is to that carbon. 3 plus 1, isn't the math hard in my class? 4. Look at the center carbon. How many bonds to this carbon right here? 2 hydrogens, and this bond, and this one. 2 plus 2, isn't the math hard? 4. And the last carbon here. Let me clean this up a little. We look at that last carbon. It's got 3 hydrogens and this bond to it. 3 plus 1 is 4. So each one of those carbons in propane has 4 bonds to it. And that's called the the condensed form. Now, one thing, my software, usually I catch it, but it likes to do it, even though I tell it not to, doesn't always listen to me, is on the end carbon here, you can have right or left justified hydrogens. And this means there are 3 hydrogens on that carbon. Most of the time I'll do this, sometimes I'll do this, or my software will do that. So there's always 4 bonds to carbon. Now, one of the things I like to do in this class is share the fun. And why don't you try putting in the hydrogens for this molecule called butane? Remember, carbon always has 4 bonds to it. And if it doesn't, the remainder are hydrogens. So you have to know how to subtract and add up to 4. And when you're done, give me a thumbs up. And for those of you who finish early, I try and give everybody time to finish. If we were in a classroom where I could see all of you, I'd say when you're done, look up and smile. I get to see a lot of smiling faces, which makes me happy. See how sneaky I am? And this is part of learning how to draw alkanes or organic molecules. There's always 4 bonds to carbon. In fact, one year, a couple of years ago, it's been more than a couple, 2 very top students at the last class, they gave me a t-shirt. If it was warmer, I'd wear it. And it has how many bonds to carbon underneath? Or no, it has on there 4 bonds to carbon on the front. And the back, it has a methane. They did real well, and they both went on to become nurses. All right. Anybody need more time? All right, let's do it. I don't have it set up today, but I'll have a poll where I can send it out. Are you done yet? But I don't have that set up. I apologize. But for next week, I will. All right, let's look at this first carbon. It has 1 bond to it. How many bonds to carbon? 4. 4 minus 1 equals 3. So it should have 3 hydrogens. Let's look at this carbon. How many bonds does it have? This one and this one. That's 2. Carbon should always have 4 bonds. 4 minus 2, isn't the math hard? Hopefully all got this one right too. So it has 2 hydrogens. Let's look at this carbon. It has this bond and this bond. Again, 2 bonds are ready from the carbon atoms adjacent to it. By the word adjacent means next to it. And again, carbon should always have 4 bonds to carbon. 4 minus 2 is 2. So this has 2 hydrogens. Isn't this hard? And it is, if you don't know this, the last carbon. it has only one bond to it, but carbon should always have four. So 4 minus 1, the remainder are made up by hydrogen. And that would be how you draw it. Now, once in a while, it does strange things like that, my whiteboard tablet. So you could have drawn it this way, or if you want to put the lines in, which I like to, you don't have to. And this is called butane. And if I ask on a test 3 points, draw the structure of butane, which I can, you would do this or this. Either one would work for me. Remember, there's always 4 bonds to carbon. Let's do one more. These are fun. Remember, I'm an organic chemist. Why don't you put in the hydrogens for this molecule? And I won't tell you the name. We'll learn that later next week. And while you're doing that, it's time for a commercial from Dr. White. Don't forget, tonight from 6 to 7:15 on Zoom, and it's in your syllabus. It's also on the first login page of the D2L Chem 170. I will have my office hour. And if you have any questions, come on by. What I'll do is I'll have a screen sometimes up, but if you see like somebody searching the internet and you log in, that's me, because nobody's around and I'm on the internet looking at neat stuff. Just say something and you'll get my attention. Remember, there's always 4 bonds to carbon. 4, 4, 4. And when you're done, give me a thumbs up. I forgot to ask, how many of you have read about me and ratemyprofessor.com? Well, you'll find out this semester if that's true. It is, but you'll find out. I think I have the most in the whole chem department at ECC and also at COD. And at both schools, I'm a 5.0. Am I good? Never mind. I better get off my ego trip. All right. Anybody need more time? Going once? Going twice? My turn. All right, let's look at the first carbon. How many bonds to it? 1. 4 minus 1 equals 3. Why am I doing this? Because there's always 4 bonds to carbon. So that means this has 3 hydrogens. If I look at this carbon, there's 1 bond to it. Line is a bond. Again, carbon should have 4 bonds to it. So 4 minus 1 is 3. So this has 3 hydrogens. But now, let's look at this one. Now it's getting tough. Let's look at this carbon. How many bonds to carbon? Oh, one thing on a special note. If you are colorblind, let me know and I will work out a way to help you. When I worked in the chemical industry and managed both quality control and research labs, over the years on 3 occasions, I had chemists working for me who were red-green colorblind. When they had to do certain color tests, we'd have someone else help them out. So, but anyways, I like to use colors in here, mainly red and black, but here we have 1, 2, 3 bonds to it. And How many bonds to carbon? 4. But there's already 3. So how many hydrogens do we put? 1. So everybody with me on that? Again, count the lines, count the bonds. 1, 2, 3. There should always be 4 bonds. 4 minus 3, what's left over is a hydrogen. Now let's go to this carbon right here. There's 1, 2 bonds. 4 minus 2 equals 2. So there's 2 hydrogen. Remember, 4 bonds to carbon. In about 3 weeks, I hope none of you are having nightmares saying, how many bonds to carbon? And Dr. White's doing this. Actually, I've had students have told me that they can't, it pops up in their brain, which is a good thing. All right, next carbon. How many lines or bonds? 1, 2. There should always be 4 bonds to carbon. 4 minus 2 is 2. So I'll have 2 hydrogens there. And finally, the last carbon right here. How many bonds to that? 1. There's always 4 bonds to carbon. 4 minus 1 is 3. Isn't the math hard? So this is the structure, and let me write it nicer. And if you didn't want to put the lines in, you don't have to. I do, so they stay straight. So one of the important things that'll help you on test 1, test 2, test 3, test 4, and the final. Whenever you write an answer down, how many bonds to carbon should there be? 4. If it isn't, it's wrong. In fact, when I'm grading, if I were grading with a red pen, if we were face-to-face and you had printed out and written it, which we won't in this class, but if we did, my eye tells my hand it's wrong. It doesn't even have to go through the brain, my brain. If I see, and I've seen students who've written 6 bonds to carbon, it takes me a couple minutes to stop laughing when I see that. And the red pen goes wrong. So there's 4 bonds to carbon. And right now you're learning how to draw structures. Now there's something which we won't get to until week 15 or 16 called structures, condensed structures with parentheses. And by the way, I'll never ask on a test, what's a condensed structure or what's a condensed structure with parentheses. But I will talk about, use this in class with this one. This is the same as condensed structures, but uses pair of parentheses with a number to show a repeating unit of a molecule. See board for examples. I better get to work. And remember, and I do it too, that molecule has 8 carbons. Now, I will tell you this. This is called octane. Wait a second. That name sounds familiar. How many of you have ever heard of the octane number for gasoline? And if you go to a gas station, you'll see you have a couple of choices. They have different octane numbers. And back about 1905, or give or take a year or 2 or 3, when gasoline was first starting to be made and used in the gasoline engine for cars, the gasoline at that time, they didn't know about additives that caused the least knocking or problems with the engine was the one that had the most octane. And that's where the name octane number comes from. Now, If you notice here, I have a CH2 repeating. How many times? 1, 2, 3, 4, 5, 6. And the condensed with parentheses, you could also write octane, CH3, bracket or parentheses. The repeating unit is CH2. And how many times is it repeating? 6. And that's how you do that. Now this, I will not use until, because it's harder for students, till we get to some molecules with 18 carbons. And it's just quicker to write it where you have 16 CH2s instead of writing up here CH2, 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 and so on, 16 of them. But most of the semester, until we get to that, I'll do this. Now, on a test, if you want to use parentheses, feel free to. I have a piece of paper signed by the Board of Regents of Michigan State University saying I know this stuff, otherwise known as my PhD diploma. But when we get into this where I'll use this, I'll remind you what it is. Now, switch is off. If you go on the internet, and let's do that. That's not the internet. Notice over here, octane, the very top, that's called the line method. I know some instructors like to teach it for alkanes. I don't, because it's very confusing to students. And I'm not trying to confuse you. I'm trying to help you learn it. And here they have the extended view, which they should have had condensed. And here they have models. And here they have a 3D molecule model, which is totally worthless in my mind, other than it looks pretty. But in the line method, every bend in a line is a carbon, every end of the line is carbon. So if we look at octane, 1, 2, 3, 4, 5, 6, 7, 8. Same as like down here. I will not use this other than rings, because this will help you out. I can do that, and I know it quite well, but it's easier for students. Now, while I'm at Wikipedia, and by the way, the first couple of years I used to call it Wikipedia, and my students would yell, "No, it's Wikipedia, Dr. White." They finally trained me how to say it right. For organic chemistry, and most chemistry, but I can only say for sure for organic, 99.9% of the stuff in Wikipedia for organic chemistry is correct. Why? Because for a number of years now, it's had many people, including Dr. White, me, police it. And I have the credentials. If I see a mistake, I can log in and say this needs to be changed, and it gets changed. So if you ever want to learn about organic chemistry or look up something in organic in Wikipedia, it will be correct. I'd bet on it. Oh, I should tell you something personal. If I tell you I bet on it, I've already known I've won. So never bet with me, because if I say I bet, I already know I've won. So that's how you do parentheses. We won't do it until later this semester when we get into what's called fats and oils, where you have structures with 16 and 18 carbons with a lot of CH2 groups. So this is organic molecules. Let's talk about cyclic organic molecules called cycloalkanes. And these are, and I'll never ask you, what's a cycloalkane? And here we will use the line method. And these are represented by polygons, many-sided structures. And here the rule, I'll never ask you what's the rule. Each bend of the line is a carbon. Now I'll combine both the line and not line method. And I don't know if that's the right terminology, but you can do line for both. Each end of the line is a carbon, each intersection is a carbon. Hydrogens are not shown. And let me show you what that means. You can tell I'm rusty because I'm going back to the screen where I should go to my whiteboard. By the way, write down your diary. Today I saw Dr. White write out carbons actually in a ring. Now, when you draw rings, don't forget, I've been doing this a few more weeks than you have. Yeah, like a few more decades. But 4 bonds to carbon. And you don't have to write this down. Well, you can, or you can come back. Now, this is the last time you'll ever see me draw a ring with carbons in it, because organic chemists don't. We're lazy. Now, let's look at this. How many carbons in it? Remember, you got to know how to count up to 10 now. And a carbon is the letter C. There's 6. Now, to draw rings in my class in organic chemists, each bend in a line is a carbon. How many carbons? 6. So for a 6-membered ring, let me see if I can do a better one. I have software that does this. That's not too bad, not too great, but this is how you draw that. Each bend in a line. Let me see if by the way, have you ever heard people say they have good and bad hair days? Sometimes they have good and bad ring drawing days. That's better. So if we look at here, 1, 2, 3, 4, 5, 6. These are the same. This is the way I'll draw this. By the way, this is called cyclohexane. And I'll teach you later on how to know that cyclohexane. And let's do something real quick. Well, first of all, I'll let you go on in case you want to write that down. So each bend in a line in a ring is a carbon. You don't show hydrogens. Now, turns out, and I've learned this over the years, Dr. White and Mother Nature love rings. Students don't, because you don't see the hydrogens, but that's life. Has everybody seen cyclohexane from Wikipedia on the screen? Thank you. And notice they have software and it draws a very nice ring. And this is how I'll do it. Each bend of the line is a carbon. Now, if you have 5 carbons, it looks like this, a pentagon, 5-carbon ring. Now, the way I draw them and the way I look at them, how many of you ever played Monopoly? It looks like the little green houses you get in Monopoly. Oh, it's time for us. I just remember when I was about 7 or 8, my sister, I have 2 sisters, one 7 years older, one 7 years younger. I'm in the middle, literally. But anyways, before my younger sister was born, if I got sick and my sister would get sick or one another, like a cold, and we have to stay home from school, we'd play Monopoly, and we played cutthroat Monopoly. Whenever somebody went to the bathroom, the other person would steal from the bank. Don't tell my sister I said that. All right, now, other rings. Oh, that looks bad. You call that a square. I call that a ring because I'm an organic chemist. This has 1, 2, 3, 4 carbons. We'll learn the names. This one had 5. Each bend in a line is a carbon. No, that's not a square. That's a ring. And in penicillin, there's a 4-membered ring. So these things exist in the real world. Next, everybody see that on the screen? That's not a triangle, that's a ring, because it's organic chemistry. Each bend in a line is a carbon. 1, 2, 3. So that's how you draw rings, and we'll practice it more, but I just wanted to cover it now. You can tell I'm rusty. All right. Now, there's some definitions I'll use. I'll never ask on a test, but what are isomers? But I'll use the terminology. Isomers are compounds with the same molecular formula, but different structural formulas. Click, the switch is off, and let's do an example. This is called pentane. It's got 5 carbons. And this is has another name. I won't give it to you right now. And these 2 molecules are isomers. Notice they have the same number of carbons. This has 5 carbons. This has 5 carbons. This has 5, 10, 12 hydrogens. This has 6 plus 6, 12 hydrogens. So they have the same number and the same type of atoms, but they're connected differently. That's called the structural formula. This is what I mean by structural formula. I'll never ask this on a test, but it's a word I'll use sometimes later in the semester. And when I do that, I'll remind you what is an isomer. Now, personal story, do I have time? I do. I remember a number of years ago, I was watching TV on my favorite lazy boy chair. I've had them for decades, a number of them. And I'm watching a cable show and they switch off to commercial. And I started laughing. I almost fell out of my chair. Why? It was a cosmetic company. By the way, cosmetics and personal care items are sophisticated organic chemistry. I'll talk later on. Nail polish remover, especially nail polish or makeup. A lot of that is very sophisticated organic chemistry. So is perfume. That's organic. Why? This is getting serious. It's everywhere. Anyways, this cosmetic company, and you know what the name of it was? Isomers. I started laughing. I said, I wonder if they're really selling isomers or not. All right. Now, let's go back to the other slide for a second. Oh, I know where I left it on the other slide. Now, does everybody see isomer slide on their screen right now? Thumbs up, people. Thank you. Now, we look at these 2 molecules, A and B. Well, how do I differentiate? If I were to send you a letter or an email, or even more importantly, if it was in a legal document like a contract or a patent, that's a legal document, how do you identify one from the other? And that turns out not to be a trivial question, a very important question. And what happened was around 1910, it started in the world to be an important question that had to be answered. And it was delayed because of World War I, which was 1914 to 1918. And how do you name molecules, organic molecules? And the word nomenclature is just a fancy word for name or naming. So I told you you learn a lot of fancy words in my class this semester. And it turned out the countries of the world, 134 of them, including the United States, came together and signed a treaty. And this treaty created an international agency that's main mission was to come up with a set of rules for naming chemicals. And the bulk of those rules are organic chemicals. And this is overseen by the group, and the acronym is IUPAC. And I'll never switch this off, ask you what IUPAC is, but it's cool to say International Union of Pure Applied Chemistry. Wasn't that cool? Now you know I'm an organic chemist. And if you go to my favorite search engine, Google, and you put in IUPAC, you can go to their website. And here's the IUPAC website. Now, they're headquartered in Geneva, Switzerland. I forgot when they officially established. I think it was 1920, but give or take a year or two. IUPAC's main mission is to develop and keep the rules for naming chemicals. And most of those are, who are we? What do we do? They got a lot of more stuff, but their main mission in life is to create the rules for naming chemicals. And they did a wonderful job. The job IUPAC did is just amazing. Any molecule, if you name it correctly using the IUPAC rules, you can only get one name. Again, and I've never seen an exception to this, and I've been doing organic chemistry a long, long time. Any molecule only has one correct IUPAC name. And from the IUPAC name, if you know what you're doing, you can only draw one molecule. And that allows people like me to communicate in both publications, and I have a number of publications of work I've done in different journals and patents I've done and others that use IUPAC nomenclature. And this semester, you will learn for different functional groups, IUPAC nomenclature. Now, I will tell you on test one, 50% or roughly 50% of the points will deal with nomenclature, because that's the first thing we're going to spend time on. That's an important foundation. And it's not the most exciting thing. The exciting thing is doing the actual reactions. And later on, it will cut down, but the first test. So this is something you should know. Now, the IUPAC rules start out with the name of alkanes. And I'm only going to ask you to learn some of them. Now, if you notice here, this comes from the book, which I had told you don't have to buy. So what I have created does everybody see alkanes, IUPAC names on your screen now? Thank you. This table you need to learn. If you don't learn this table, you've just lost 50 points on test one, test 2 and 3, about 40 points on the final, about 40% of the points, Test 4 is a little less, but you need to know it. Methane, 1 carbon. Propane, oh, that's your old friend, 3 carbons. Pentane, 5 carbons. Octane, 8 carbons. Decane, 10. Now, this list goes on to thousands, and I know a lot of them up to a couple hundred, but you don't use them really up to 20. 11 is undecane, 12 is dodecane, and so on. But for this class, this is about everything we do until we get into fats and oils, and then we'll use what's called common names. But the IUPAC names, you have to know this chart. How do you learn it? I would start this week. Write down methane, 1 carbon. Methane, 1 carbon. Do that 5 times and say it. Just like I told you about the story of the 2 students, by doing it that way, you will memorize it. Now, what is the importance of learning this table? Let me show you. On test 1, you might see a problem, 3 points each. Hint, draw the structure for, and one of those multiple part, not multiple choice, is propane. Well, how do you do that? Well, you've learned this table. Propane, how many carbons? 3. Again, you learned this table. And by the way, this is in the lecture section of D2L, and it's cleverly named alkanes. IUPAC names the number of carbons atoms. And now you know propane has 3 carbons. So now I'll draw in my 3 carbons. You don't have to put the line in, I like to. And you also have to put in the hydrogens. And sometimes here I'll say, draw all hydrogens. So you know there's 4 bonds to carbon. This first carbon has 1 bond, 4 minus 1 equals 3. And I know go to the second carbon, it has 2 bonds to it. 4 minus 2, because there's always 4 bonds, is 2. And the last carbon has 1 bond to it. There's always 4 bonds to carbon. Therefore, that has 3 hydrogens. And let me draw it nicer. And that would be the answer. Well, if you don't know that table, you can't do this. Now, if I look at the clock, even though the, how should I say this, the catalog says till 3:50, that's based on 3 10-minute breaks. Because we're not taking 3 10-minute breaks, I end a little earlier. Now, one of the things you'll learn about me and learn right now is my religion is Jewish, and my grandmother, my mother's mother, was probably one of the finest people I've ever met in my life. Grandma Greenman, what a great lady she was. And Yiddish is a language, a mixture of German and Hebrew. And whenever we'd leave after we were visiting her, she'd always say to us, especially to me and my sisters, Gehen gesund. Gehen gesund means go in health. And since I started teaching on Zoom with the pandemic and health problems because of that, I always end my lecture, and also you'll see my emails, Gehen gesund, and I'll say that to you now, gang gesund. Then the next thing I'll do, which I stole from Granny of the Beverly Hillbillies TV show, at the end, she'd go, goodbye. And I'll do that. Gang gesund, goodbye. Stole that from Granny. I'll see you on Monday unless you come to my office hour. I'm done for today. By tomorrow morning, there'll be a video on my YouTube channel. If you have any questions, I'll stick around for a couple minutes. Or don't forget, you can come to my office hour tonight from 6 to 7:15, a different Zoom login that's in the syllabus. With that, I'll say, gang gesund, goodbye.